So the first one we solved was by graphing. You could have it in standard form or in slope-intercept form. This particular one is in slope-intercept form. And so you literally just graph the two lines, and then where they cross is the answer. So for slope-intercept form, you start at the slope, the intercept here, which is the y-intercept, -3. So on the y-axis, we're going to start at -3. The slope tells me how to move. 2/3 is up 2 and to the right 3. So I'm going to walk from this point up 2 and over 3. And so my next point is going to be right here. And then once I have that, I'm just going to connect those dots and go on to the next line. All right. So the next line, the y-intercept is at +2. So I'm going to start up here at +2. My slope is down 1 over 1 because it's -1. Now, you can actually walk all the way down until it crosses the line. This kind of gives you a better picture of where you're going to cross, because sometimes you're going to, when it's that close, you might get the wrong spot. So you can say down 1 over 1, down 1 over 1, down 1 over 1, and you can see that this is where you're going to cross that line if you walk it all the way down with your slope. And so this point right here, as well as the 3, -1, are going to be on that line. And you can see that it's going to cross right there. So your graph should look like this, and then your answer is going to be this right here. So your answer should look like this. It should be your x value of that point and your y value of that point. So this is your answer. So this third page, to go all the way because the graphs take up a little more space, but the third page is solving by substitution. So with substitution, your first step is to get a variable by itself. You'll see that in this first group of questions, you have a variable by itself for one of the equations, but then there are times when you do not have a variable by itself. And so I'm going to show you both ways. When you have a variable by itself, it's kind of already ready to go. You're going to take this right here and plug it into the other equation for that y. The y is by itself. We're going to take that whole group and replace the y with that group. So I have -4x plus 3y. And instead of y, I'm going to write what y is from the second equation, 7x plus 7. It does not have to be the second equation. It just works out this way. And it does not have to be y that you solve for. All right, but it has to be a variable by itself. Once you have substituted that variable, you're just going to solve. So in this case, I am going to distribute that 3 times 7x, 3 times 7 equals -13. I am going to combine my like terms on the left-hand side, -4 and +21. I'm going to move that 21 over. And then I will divide by the 17. Now, once I solve for this, I only have one of my variables. I know that x equals -2. That's great, but my answer must be an xy, okay? So I have to take that -2 and I have to plug it back in to my equation to solve for y. We know that y equals 7x plus 7, so I'm going to say 7, and instead of the x, I'll write -2 plus 7. So that's -14 plus 7, so my y value is -7, which means my answer should look like this. -2, my x value, -7, my y value. Up here. And we'll just start this one. We won't go all the way through it. So when I look at this, I do not have any variable by itself. What I'm going to do is I'm going to look at every single variable that I have and figure out which one is the easiest to get by itself. Clearly, these are not easy because if I divided everything by either one of these, I'm going to get a fraction. So if I look, the x is obviously the easiest one to get by itself. So I'm going to take this second equation here and I'm going to get a variable by itself. How I'm going to do that is I'm going to move this -5y over. So we'll add the 5y over. Now we have x by itself equals that 5y minus 8. And now this looks just like the equations I just solved for. I have a variable by itself, the x. I'm going to take that group and I'm going to plug it into the other equation for x. So I'm going to say 3, and instead of x, I will say 5y minus 8 minus 15y equals negative 4. So if we do this one, and this is a special case, so we'll keep going. We have distribute our 3. We have 15y minus 24 minus 15y equals negative 4. What happens to my 15y's? They cancel. I get negative 24 equals negative 4. When does negative 24 equal negative 4? Never. So this is a no solution. If I had gotten negative 4 equals negative 4, that happens always. And that would have been all an infinite number of solutions. It would have been one of my lines, actually. Either of those lines you could have circled and said, this is my answer. Infinite number of solutions had it been a true statement, but a false statement is no solution. So you could have something like that as well. All right, so the whole goal of elimination is to eliminate a variable, all right? It is often called solving by addition because the way you eliminate is you add the two equations. The only way adding two equations will eliminate a variable is if your coefficients are opposite numbers of each other, like this first one. I have a negative 1x and a positive 1x. If I add those, I will eliminate my x. That is the goal, right? Over here, we're going to have to multiply these by something in order for that to happen. So you could have these types. You could have where it's already set up for you and all you have to do is go straight to the addition. Or you may have to multiply your equations to get opposites so that when you add, they cancel. So if you have them already opposites like this first one, you are ready to just go ahead and add. And so we would just take this and add the two equations. Negative 1x and positive 1x cancel. Negative 3y and positive 7y give us a positive 4y. And negative 13 and positive 21 give us a positive 8. And so we are ready to solve for y. We're just going to divide by 4. We know that y equals 2. To finish solving this, we also have to have an x variable. We can plug that y into either one of these equations. It does not matter which one. So if I were to take the top one, I have negative x minus 3 times y, which we now know is 2, equals negative 13. I have negative x minus 6 equals negative 13. I'm going to add my 6 over. Negative x equals negative 7, and then divide by that negative 1. So we know that x equals 7. So my answer should look like this. X value first, then y value. 7, 2 is my answer. That is the point where if I were to graph it, they would cross. Same thing. For something like this, I am going to look and see what's the easiest 2 to get to the same number, right? Like for example, if this had been 2 and 4, I wouldn't even touch the top one. I would multiply the bottom one by negative 2, right? Neither one of these are actually multiples of each other. So I'm going to have to multiply both equations here. So now I'm going to think, which is going to keep my numbers the smallest. Honestly, that's how I look at this. It will work whichever variable you want to eliminate. But for 9 and 4, you're going to have to do a much larger common multiple than something like 3 and 2. So I would choose the y to eliminate here because I can get to 6 with smaller numbers, right? So the least common multiple between 2 and 3 is going to be 6. I need one of these to be positive 6 and one of these to be negative 6, all right? Doesn't matter which one, all right? So I can multiply the top by 2. That will give me a positive 6, which means I need to multiply the bottom one by negative 3 to get a negative 6. And I have to multiply every single piece of it. So I'm going to distribute the 2 through. I will get 18x plus 6y equals negative 30. Multiply the negative 3 through, I get negative 12x minus 6y equals 0. All right. Now I can add down and eliminate something. And so that's what I'm going to do. Add down. I am going to get positive 18 and negative 12 give me 6. The y's cancel, negative 30 and positive 0, negative 30, and then divide to solve for my x. X equals negative 5. And once again, you can go back to either equation to solve for what your y value is. So 4 instead of x, I'm going to write negative 5 plus 2y equals 0. 4 times negative 5 is negative 20. Add the 20 over, and I get y equals 10. So my answer is going to be my xy. So my answer here is negative 5, positive 10. A plane traveled 728 miles each way to Cleveland and back. The trip there was with the wind. It took 7 hours. The trip back was into the wind. The trip back took 14 hours. What is the speed of the plane in still air? What is the speed of the wind? All right. So you can set up a variable. You can say, well, x is going to be the speed of the plane, and y is going to be the wind. All right. And so you can set these up just like you would anything else. You can set up your distance, rate, and time chart if you want to. Rate and time always equal your distance, right? We don't need something quite that big. All right, so we have our rate and our time and our distance here. We know the distance. What is the distance? 728, right? So on the way there, they were going with the wind. So their rate on the way there is going to be the airplane's speed plus the wind, because the wind is helping them. So we're going to say x plus y, because the wind is helping them. And we know how long it took them. It took them 7 hours. All right. On the way back, they were going against the wind. So it hurt them. So we're going to take the speed of the plane and we're going to subtract the wind. It slowed them down, which is why, by the way, it took 14 hours. If it's the same distance, it should take longer if the wind is hurting you, right? It should take less time if it is helping you. And so if I were to multiply these across and get my equation, I would see that 7 times x plus y equals 728. And 14 times x minus y equals 728. Now here's the thing about these. Most of the time when I give these to you, that number is going to be divisible. What I mean by that is if you take 728, you can go ahead and divide out the 7. And you will get x plus y equals 104. And then if you, for the next equation, you can actually divide that 14 over, and you will get x minus y equals 52. What do you notice about this? There's an easy way to solve this now, isn't there? Elimination. I already have an x and a y set up for you, okay? And so it's always a good idea, even if you get decimals, to divide that guy out, because you can go ahead and get rid of it and it's already set up with an x plus y, x minus y, and it's a very easy elimination, okay? Because I know they're equal to the same thing, but even if you set them equal to each other, you still have two variables, right? So setting them equal to each other doesn't really help because you still have two variables, but elimination helps here. So I can now just add down. The y's will cancel. I will get 2x. Over here, I will get 156. Divide that by 2. X equals 78. All right. So I solved for X. What did I solve for? The plane or the wind?
The speed.
Yeah, the speed of the plane. So the plane is going 78 miles per hour. All right. All I have to do is plug it in over here. If the plane is going 78 miles an hour and together they're going 104, I can just subtract and I will get that the wind here is 26 miles per hour. You can just plug it in. 78 plus y equals 104, right? And when you subtract, you get 26. So this type of problem usually will work out quite nicely for something like elimination. So for something like this, you will read the problem and you should have two things that pop out to you that are variables that you don't know. So Haphazard School is selling tickets to a play. On the first day of ticket sales, the school sold 12 senior citizen tickets and 10 child tickets for a total of $160. The school took in $76 on the second day by selling 4 senior citizen tickets and 9 child tickets. Find the price of the senior citizen ticket and the price of the child ticket. You can clearly see what's going to be your variables, right? So they are asking in that last question the price of senior citizen and the price of child. So you can say S for senior citizen, C for child, it doesn't matter. You can say X for senior citizen, Y for child, as long as you note somewhere on here which variable represents what. And then you're going to set it up based on the sentences above it. They sold 12 senior citizen, that's 12x. And they sold 10 child, that's 10y. $160, right? The next day they sold 4 senior citizen, 9 child tickets for $76, right? And then you can solve this one by elimination if you want to, right? First of all, I will say you can actually reduce these if you can. It doesn't really help you as much because you're still going to have to get to a common multiple. But right here you have 4 and 12. I could multiply this second equation by -3, right? And I'll be set up for an elimination problem. And so all of these word problems are going to set you up with an X and a Y for 2 different equations, and then you're going to solve by one method, either elimination or substitution. All right? Whichever one you want to do on these.